All right. Good afternoon. Garth, are you hearing me okay?
I hear you well. And Dr. Jah has just joined us as well. Hello,
Good.
Dr. Jah, thank you.
Yeah, how's it going?
Are you hearing us okay?
Yeah, I can.
Great.
I will ask that people just give me because I've been in meetings all day, so I just want like a summary of who you folks are, all that other stuff, your interests.
Absolutely. Yes,
orient me.
Absolutely. Shall we just jump in and I can start with that intro?
I think that's fine. I want to make a note that we are recording this and we'll post a slimmed down version onto our YouTube page that will send a link out to all of our participants. So I just wanted to let everybody know that. That's a thing we've been doing so far. But I'll let Melissa Pork go ahead and tell you a little bit about us and our mission and what we're doing here.
All right, so good afternoon, everyone. Melissa Poore here, reporting from Bishop O'Connell High School in Arlington, Virginia. We have students here. We have mentors around the nation that also have their students gathered in their classrooms. And this is our fourth meeting, I believe. We have received a NASA grant to launch a 3U Cubesat with smaller SlimSats within it. So each school that's part of our mission will be working with an individual payload that will be integrated into our 3U satellite and launched in 2026. Today, we have a school from District of Columbia visitation. We have 8 students from the mission that actually came all the way here to our school in Arlington so we could collaborate together, our team members. So, Dr. Jah, before we start, I do have a student here, Hope Dixon, who is going to introduce the topic that we want to discuss this evening.
And I'll say that I have a hard cutoff in 27 minutes.
Got you. So let's go ahead and start. Thank you so much. This is Hope Dixon.
I'll be quick. Hi, Dr. Jah. It's so nice to meet you. My name is Hope Dixon, and I'm a senior at Georgetown Visitation in DC. I first started getting involved with STEM with Ms. Poore when she led a similar CubeSat mission at my elementary school, and I've been interested in aerospace engineering ever since. I was telling the girls from my school about space debris just as we were preparing for this, and we're really excited to be here to hear about the research you do. I was looking at Wayfinder, and I just think it's shocking to see the comparison between the active satellites that we're using versus those that have just been left. I think a lot of people my age think of space as this huge space that has unlimited space, but it's really not as big as we think it is. And so I think as our world becomes more environmentally conscious, we should also be aware of the environmental impact in space of leaving things unused to just take up space and make clutter. So we're really excited to hear from you, and we can't wait to learn more. Thank you.
Awesome. I appreciate that.
So with that, I want to say that Dr. Jah is a professor among many things he does at the University of Texas at Austin, where I also went to school and my parents and grandparents went to school. And I saw the vast capabilities of the interface during a tour. And I really appreciate, Dr. Jah, you allowing us to create interactive tools to engage in your platform and get the most out of it. So I would like to introduce Dr. Moriba Jah. Thank you for being part of our mission.
All right. Many thanks. Aloha. And great to chat with you all. And yeah, appreciate the intro and all that. So let's jump into it. I'm going to go ahead and see if I can share my screen here. So I'm just going to do that, and hopefully people can see that. So can somebody just tell me yes?
Yes, that looks great. We can see it.
Okay, cool. So look, how did I get into this whole thing? And I'll get into what the dots mean here soon. But some time ago, I moved to this beautiful island, not Hawaii, but Maui. in the Hawaiian Islands. And I used to work for NASA in the beginning of my career, specifically on Mars missions. And I worked at NASA for like 6 years, sending stuff to Mars, including rover Spirit and Opportunity. But then I went to the island of Maui for a conference and fell in love with the island. And, my family and I, we chose to try to relocate to Maui. And I was able to find a job on Maui. So I left NASA to work for the US Air Force as a civilian, as a government employee civilian. And on the island of Maui, the US, now the Space Force, operates this really cool facility on top of Mount Haleakala called the Maui Space Surveillance System, which you can see here. And we're zoomed in, pretty zoomed in, and the circular facility that you see there close to the top is a 3.6 meter telescope, but then all the other buildings are, telescopes supporting the Maui space surveillance complex. Now, with those telescopes living on Maui, I didn't realize it yet because I was focused on stuff at Mars. When you zoom out from those telescopes are part of the Department of Defense's space surveillance network, which are detecting and tracking as many human-made objects as possible down in size to the size of a cell phone. So this is kind of a near real-time prediction of some of the traffic. The blue dots are satellites that are active, that they're working, and anything that's not a blue dot is trash. So these white dots, the pink ones, all those are garbage. And so in 1957, we launched Sputnik. So there was only one space object. And now in 2025, we're tracking upwards of 50,000 objects in space, ranging in size from the cell phone all the way to the space station in different orbits. And the dots don't represent the size of the object, just the location, but you can already see that it's very well populated. And unfortunately, most of the stuff that we launch is equivalent to a single-use plastic, meaning that we have a linear economy in space whereby everything that we launch, every satellite that we launch is destined to be junk, except a couple of things like, the Dragon crew space vehicle and these sorts of things that go to the space station. Those are the only, reusable, recyclable spacecraft, but everything else is destined to be junk. And the thing is when the objects stop working, mostly because they run out of fuel, they die on orbit, and they stay on orbit for many years, sometimes decades, sometimes even centuries, depending on the altitude of them. So I'm just kind of painting the orbit here so you can kind of see its relative distance. So these Starlink satellites, for instance, are at about 500 kilometers above the Earth's surface, meaning that, me being here in Austin, Texas, you folks are closer to most of the satellites in low Earth orbit than you are to me right now. So even though people think space is this really far away place, it's not that far away, is what I'm saying. And what we actually need is, I'm trying to remember the name of the high school student that introduced me again. What's her name again?
Hope Dixon.
Hope. Right. So, Hope was correct in saying that we need to be moving towards environmentalism and sustainability. And one of the things that we can get from looking at waste management principles is the idea of circularity. or circular economy that would first and foremost prioritize design, developing, launching, and operating reusable and recyclable satellite systems. That's the main thing that we need. And if things can't be reused or recycled and they have to be single use, then we need to dispose of them responsibly. And right now, we're not doing that. Right now, there is a rule that says you have anywhere between 5 to 25 years after your object dies for it to no longer be in orbit. They don't say that you have to remove it, but you're responsible for it being gone. And so one of the things that people have been doing is they've been launching into low Earth orbit because they know that if their object dies within 5 years, it's going to re-enter and burn up in the atmosphere. So I'd like to say that recycling is like a global myth, in that only 9% of all plastics are actually recycled, because the other 91% are either incinerated, find themselves into landfills, oceans, or dumps. And right now, our biggest method of getting rid of things is to abandon them on orbit and then let Mother Nature figure it out and get rid of it through atmospheric incineration, which in and of itself, as you can imagine, when you incinerate plastic, the particles created from that incineration are pollutants. So satellites burning up in the atmosphere are also pollutants of the atmosphere. We need to design satellites out of materials that, if they're going to be incinerated, as a mechanism of disposal, that they don't pollute the atmosphere during that process. And oh, by the way, if you've been watching the news, you know, here's here we are with the US. You can kind of see, zooming in here to Gulf of Mexico, and you can kind of see Starbase is someplace, you know, over here. You can see South Padre Island, that sort of stuff. So you can see the Starbase is somewhere in there. And, you know, interestingly enough, you know, some of these rockets are exploding. And very recently, there's a lot of debris that was raining on different places in the Caribbean, Turks and Caicos included. And people have been frightened of this sort of stuff. And if you Google objects re-entering and landing in places, there was another set of pieces of rocket that landed in Poland. And so this, you know, I'm Chicken Little saying that the sky is falling, and we need to do something about that as well. Now, one of the things I want to show here too is this thing called a conjunction streaming service that we've developed at UT Austin, that basically shows which objects or pairs of objects are predicted to crisscross each other within the next 20 minutes continuous. It's a continuously sliding 20-minute window. Pairs of green objects are both working. Yellow dots here are one object's working, one object is dead. Red dots, both are dead objects. And the missed distances are up to, you know, 10 kilometers, 6 miles. The relative speeds on the histogram on the upper right is 15 kilometers per second. So that's 15 times the speed of a bullet. And the smallest thing that we're tracking is like the cell phone size, which is many times the size of a bullet. So if a cell phone size object is traveling at 15 times the speed of a bullet and hits anything, it's a bad day. So that's not a good thing. And space is just becoming increasingly cluttered because, again, we keep on launching single-use space systems. But the answer is circular principles, having a circular economy, design, operate, and launch reusable and recyclable satellite systems. And for some objects, we need to remove these things. But if I click on some of this stuff, like, let me see, some of these things actually have debris removal prices. Let me see if I can filter that out very quickly. So if I go removal price, show objects with removal pricing. So let's see that. And when I look at that and I click, you know, that one is 25 million to just remove this one rocket body. This other one here is an old satellite. That's 22 million for that, to remove that object. If I click on another one here, let's see, this Titan Transstate, so that's 19 million. That one's 21 million. So you can get the idea. No, these things cost more than a cup of coffee, sort of thing, right? So, but we need to start cleaning some of these. And unfortunately, much like the oceans will never be pristine again, there will always be some residue of microplastics and trash in the ocean. You know, space, orbital space, which is not infinite, it's finite, that too will always have some amount of trash in it. It'll never be like it was in 1956. So anyways, with that, I guess I'd like to stop sharing and just see if people have questions.
We have a question in here. I would like to introduce Dr. Jah. We have one of our mentors here. I don't think you were on the call yet. Shuttle astronaut Dan Tani, who's been
nice.
part. Yeah, so just wanted to introduce you to.
Thank you.
And yeah, so say your name and ask your question.
Hello, I'm Peter. I was just wondering if there's like a point of no return, and I'm assuming that it's like exponentially increasing the amount of space trash there is. And I'm just wondering, also, is there anything that we can do as students, that we can do? Because
Yeah, I love that.
Stay here.
And you said your name again was?
Peter.
Peter. So here's the deal, Peter. I have some good news for you. Some people believe in a point of no return, and they call it the Kessler syndrome after Don Kessler, who was a NASA scientist. As much as I respect Don Kessler, I'll say that I'm not a proponent of points of no return, because everything that I've seen in nature, when humans take their foot off the I'm acting stupid pedal, Mother Nature always seeks equilibrium. Mother Nature always seeks to achieve balance. When COVID occurred, people weren't traveling. Guess what happened? Animals that were never seen were coming out of the woodwork. All of a sudden, if you know, in Venice, Italy, you could see clearly through the canals all the way to the bottom, because things weren't getting churned up with all the vaporetti and all this other stuff. So when humans basically pause their activity in always exploiting and always this, that, or the other, nature provides us feedback of that. And the danger right now is that our collective actions are outpacing the environment's ability to provide us feedback that would be useful for us to live sustainably. We need to kind of slow down or be more thoughtful in the way we act. So this is my long-winded way of answering you to say, I don't believe in a point of no return. I believe that we should take a page from indigenous knowledge, which is, one, recognize that all things are interconnected. Two, believing in that interconnectedness, recognize that our original roles as humans is to be stewards and custodians of the environment. And three, the environment is not separate from us. We are part of nature. We are part of the environment. So we should behave as such and allow nature to give us, you know, feedback of the unintended consequences of our actions. And as far as like things that you can do, I believe that power does not reside in controlling outcomes. Power resides in our ability to make choices. And so I would like to remind you and all the students that you have power, meaning you have the ability to make choices. Like, you can't choose all of your experiences, but you can choose how you respond to your experiences. And I would say, do what you can to be educated. And when I say educated, I mean knowledgeable of the world around you and your relationship to these things. And imagine yourselves as stewards and start making decisions having that that guise of stewardship, that mantle of stewardship on you. There's tons of things that each and every one of you can do. One of the things that I can say is, you know, these days when I go and get a plane ticket on United, I have a series of itineraries, all with their carbon footprint. And the cool thing about that is I could choose the one that is the least impactful to the planet. Do I always choose that? No. Sometimes I do. But the thing is, it's an informed decision. And so being a steward is not binary. It's not all or nothing. It's doing what you can as you can to minimize the impact to the environment that we're a part of. And the reason I brought up the carbon footprint stuff is, you know, as students, one of the things that where there's no transparency is understanding, for instance, the supply chain for space services. When you go to a store, you can, you know, buy stuff based on information of how was it developed? Is it a free trade, you know, fair trade kind of thing? Is it organic? Is it this, that, or the other? It gives you glimpses into how products got from their source all the way to you, and you can make informed choices. Right now, there's all these services and capabilities that happen because of these robots in the sky that we call satellite, and nobody, including myself, has any clue what the cost to the planet and the environment is of receiving any of those services. So I think that, you know, as a student, one of the things that you could do is put on your investigative hat. And, you know, Elon isn't getting all these satellites, sourcing them from Texas. Like, these things come from other parts of the world, Africa, Asia, South America. Where are these things getting sourced from? How are those people being treated in the process of the sourcing? What's that supply chain? What's the impact to the planet of these services that we get from satellites? Not to stop launching them, but to understand what that impact is so that as a consumer, we can all make informed decisions. So anyway, hopefully that answered your question.
That was a great question.
Yes, thank you very much.
Thank you, Peter.
Garth, do you want to check our chat? And Dr. Jah, I just want to go ahead and thank you right away for this impactful talk. It is like everything stands still when we're hearing about this. Our passion is great to advance remote sensing and understand how to help our Earth more. So this other side of it, which is, you know, the downside of advancing society, we must pay attention to, and we have choices we can make.
Absolutely. No, I appreciate that. And I guess the thing that I want to say is that, you know, I don't come to you as, oh, Professor, Dr. Jah, all these accolades, this, that, and the other. To be honest with you, none of those things really mean anything. The thing that really means something is the fact that you're all in this room. We all have an interest in making things better. You're all inspired to do that. And I'm encouraging you to be empowered to just, you know, make choices, believing yourselves to be stewards. And what does that mean? So I appreciate each and every one of you, for sure.
Okay, I have another student that's come up for a question.
Hi.
How's it going?
Good,
What's
how
your
are
name?
you? My name's Kara Miller. And sorry, my question was, you were saying, how each like individual piece of like trash and like debris and stuff, like I was like really shocked by the amount and like, or I was really shocked about like how much it costs to grab like each individual like piece. And I was just like wondering like what makes that cost? Like, is it based on like the materials you guys need, like to like like get that, or like for each individual piece, like how are they collecting that, and like why is it so much?
Yeah, Kara, that's a great question. So the cost is multiple things go into the cost, not the least of which is having to actually launch something that would go remove it. So, even though, SpaceX with Elon, they've definitely, with reusable rockets, have made things cheaper in terms of launch costs, but it still costs a lot of money to launch satellites, especially ones that are going to grab school bus size objects to bring those things down. So a lot of it is just in the launch costs, and being able to then find a way to rendezvous with these objects which are tumbling, and find ways to detumble them, and bring those in and have those things like burn up in the atmosphere and that sort of thing. So those are all the sorts of things that go into the cost. And oh, by the way, out of the 50,000 objects that we track, 10,000 are working and everything else is trash. And out of the 10,000, 7,000 belong to Elon alone. So 70% of all of humanity's working satellites belong to a single entity.
Wow.
Go ahead.
Also, like, obviously, like, from the points I'm seeing, like, on the screen, like, they're probably, like, not that close to each other, but, like, has there ever been an instance where, like, they found multiple pieces, and, like, does that, like, impact in any way, like, that it would cost, like, less because, like, they're, or, like, sorry if that's confusing, but, like.
No. So here's the thing, right? Things have collided with each other before, and when things collide with each other, they become tens of thousands of pieces, and each one of those smaller pieces is now a hazard that could collide with something else. So that is part of the problem, is collision risk.
Can't move. Yeah.
Thank you.
Yeah.
So we've got about 3 minutes left, and Dr. Fevig, I believe, had his hand up, and then Owen McAllister will be next. So go ahead, Dr. Fevig.
Thank you, Garth, and thank you, Dr. Jah, for joining us today. Very quick question. So as we all know, it's very costly to launch things into orbit, and so recycling certainly makes sense if it can be done. Are there entities that have a vision for this, and perhaps roadmap, for a way forward whereby we can do this?
No, I appreciate that. One of the leading companies from Japan interested in active debris removal is Astroscale, and they do have one of those in the United States, but the headquarters is in Japan. The United States, there are companies that are interested in doing that, but so far the government has not stepped up to create a marketplace for those services. I mean, governments are ultimately responsible in terms of space law for any liability for damage from space objects, but it's not, you're not going to get rich by removing trash from space. Unfortunately, people aren't getting paid for space garbage removal, and until such time, it just doesn't make companies to try sense for companies to try to do it. But part of this idea of a circular space economy that I've been proposing is for governments to get together and create that marketplace, so that not only will it advance science and technology, but it'll help create jobs and help a space economy thrive.
Thank you.
Thank you.
Dr. Jah, we have 1 minute left. Owen McAllister, if you want to go ahead with your question. If you could answer one more question, Dr. Jah, we appreciate it.
Yep, one more question. Sure.
Hello, can you hear me?
I can.
Okay, my name's Owen. I'm wondering, I'm interested about the cost of removing these satellites and debris in orbit. Is there a way to minimize that cost by taking multiple out at once?
Yeah.
And how does that work?
Yeah, so if you had a satellite that could find a way to tug these things into like some general area, and then try to find a way to bring multiple down at the same time, like certainly that would be better and would reduce the cost for sure. So great question.
All right, thank you.
Yeah, but look, unfortunately, I have this hard cutoff, but I want to say thank you to each and every one of you. Much motivation to all the students. Become celestial stewards and space environmentalists. And, as we say on Maui, love and aloha. So take care, everybody.
Thank you, Dr. Jah.
All right.
Thank you so much.
Cheers.
Yeah, thank you. Bye.
Garth, do you want to close this out? That was a great talk, I
Yeah.
think.
Yeah, sure. That was a treat. I think he gave us a lot to think about and consider going into the future. I love how he started off with, the impact we have to make is not necessarily controlling things around us, but really controlling our own selves and the decisions that we make. I like that little bit of wisdom. But yeah, that was our meeting for today. Does anybody have any follow-up or anything? Any questions or anything like that about anything? And if not, we can go ahead and close out, and I'll send everybody a follow-up email with the link to our video here so you can share it if you'd like and watch it again. And stay tuned.
Sounds good. Over and out from Bishop O'Connell and Visitation.
Bye. Thank you.
Thank you.
All right, Dr. Pevig. And everybody else, thank you so much. We really appreciate it. Stephanie, I love that you're outside. And Dr. Jah was talking about, environmental, keeping, the environment clean and being stewards and everything, and you're outside. That's nice.
Thanks, Garth. Yeah, I'm at home on the ranch, fixing to go feed cows.
Exciting.
So we're on break. Thank y'all so much. I'll show this to the kids as soon as they're all back next week.
Okay, great. Yeah, I'll have a copy for you soon.
I
Thank y'all.
appreciate y'all. Have a great week.
All right. All right. Thank y'all so much. And we'll see you next time.